Hello everyone, my name is Vijay Ahmedabade and today I am going to share my knowledge about flex sensors. As we know that the world is progressing very fastly, especially in the field of robotics. Different sensors are being used for different applications like accelerometers, force sensors, fiber optic cables, magnetic sensors, etc. The above mentioned sensors cannot be suitable in every scenario and can be costly. For example, the image processing method requires complex DSP coding as well as it also requires high resolution camera. The magnetic sensors may be incomplete in tracking the motion. The resolution obtained by optical sensor is poor. And the main disadvantage of electromagnetic sensor is that they can be affected by small interference. Also, the use of joysticks can be tedious as it requires tremendous amount of practice to control any machinery. So, most of these difficulties mentioned above can be ruled out by using flex sensors. They can be precise enough to track small motions and can be cost effective. Also, they can be interfaced with any microcontroller without any complex coding. That is why flex sensor has that upper hand or advantage over all the above mentioned sensors. You can see these are the pictures of flex sensors. Now the working. Flex sensors are the sensors that change in resistance depending on the amount of bend on the sensor. They convert the change in the bend to electrical resistance. The more the bend, the more the resistance value. See, flex sensors are analog resistors. They work as variable analog voltage dividers. Inside the flex sensors are the carbon resistive elements within a flexible substrate. More carbon means less resistance. When the substrate is bent, the sensor produces a resistance output relative to the bend radius. Here is the basic circuit diagram. Actually, on the flex sensors, we have some small micro cracks. It works on the basic principle of resistivity. As we bend the sensor, the micro cracks gets widened, and hence the resistance increases. As a flex sensor are made up of resistive carbon element, they show the property of change in resistance according to the bending of the sensor, and then they convert the change in the bend to electrical resistance. As we know that the more the bend, the more the resistance value. Then the output of the flex sensor is the varying resistance, which is converted into a voltage signal using a voltage divider bias circuit. Here we can see that the FSR is a flex sensor which has two output leads, one of which is connected to the positive supply and other one is connected to the ground through the resistors and through the resistor, and one impedance buffer is used there. In this way, this flex sensor act as a voltage divider bias circuit here. This is the observation. On the x-axis we have resistance in kilo ohms and on the y-axis we have voltage in volts. We can see that as the resistance goes on increasing, the voltage is decreasing, or we can say that as voltage goes on increasing, the resistance is decreasing. This is the observation of flex sensor. As we know that the output of flex sensor is in the form of variable resistance, and as the sensors are bent, the resistance of the flex sensor changes. This property is shown below. In the diagram you can see that when the flex sensor is in the flat mode or in its flat orientation, it has around 20 kilo ohms resistance, and when it is slightly bent around 45 degrees, the resistance increases, and again when we bend it to 90 degrees, the resistance goes on increasing because of the fact that we seen just now the small micro cracks gets widened and the resistance of that flex sensor increases, and this resistance is then converted from analog to digital converter, and then that can be used for various applications. These are some of the characteristics of this sensor. The size, approximately the size of flex sensor is around 0.28 inches wide to 1, 3, 5 or 7 inches long. We can create or we can make the flex sensor according to our requirements. The resistance range is 1.5 kilo ohm to 40 kilo ohms depending on the sensor, and its lifetime is greater than 1 million life cycles. That means that we can bend the sensor for 1 million times, and the temperature range is -35 to +80 degrees Celsius. It means that in the normal temperature range, flex sensors are very good for the usage. Its hysteresis is 7% and the voltage range is 5 volts to 12 volts. And these are some of the application areas of applications. like gaming gloves, auto control, fitness products, measuring devices, assistive technology, musical instruments, and joysticks. Nowadays, in robotics, especially in humanoid, uh, these flex sensors are used to determine the gestures of human hand, because they are filling the human intelligence into robots. So it is important to feel the uh, actions of human being on that robot. Whatever action human is performing, it is captured by using those flex sensors, and then that is replicated onto robotic arm. So in those applications, these flex sensors are used. Also in the toys, in auto control, in fitness products, gaming gloves, and horn switches, these flex sensors are used. That is all about the flex sensors. Thank you.